Did you know that construction industry compared with other industries, it has been one of the slowest of adapting innovation because of the characteristics of the construction projects? First of all, construction projects involve lot of different stakeholders: builders, subcontractors, suppliers, architects, homeowners. And in addition to that, one of the influential parties is a local state, under whose regulation the whole construction needs to be done. There are a lot of rules in construction. From one hand, it can have inhibiting effect for innovation, but from other hand, it can lead to major changes. Today we are witnessing the new coming of construction era, where extensive changes have been happening due to the technological developments and acknowledging the need for resource efficiency. While traditional construction involves assembling various materials on a building site, with workers engaged in numerous tasks such as laying bricks or installing windows, then alternative way is to build industrially. Industrial house manufacturing is similar to car manufacturing. All the house building components like walls, floors, and much more are produced in a factory rather than on-site. This approach presents several benefits that make it an attractive choice in contemporary construction. Below, we explore more closely the key reasons why producing buildings in a factory is more reasonable and effective than conventional on-site construction. Industrial manufacturing, also called prefabrication, offers several significant advantages in terms of speed and quality, which are essential in construction practices. Factories provide a controlled environment where external factors like weather and temperature do not disrupt the construction process as the works are happening indoors. This eliminates delays that might be caused by rain, snow, or extreme temperatures, which are common issues in traditional construction projects. The use of advanced machinery in factories allows for tasks to be completed with a high degree of accuracy. This precision reduces the chances of errors that can occur on construction sites due to human factors, leading to a higher overall quality of the finished product. Moreover, components produced in a factory can be standardized, meaning they are made uniformly. Standardization helps to make quality more reliable as the components are made the same way every time. As well, uniformly produced components fit together easily, speeding up the building process since there's less room for errors. Efficiency and speed are significantly improved in factory-based construction. Building houses in a factory environment can be much faster because multiple processes can happen at the same time. For example, while the wooden frame for building is assembled, another element can be painted and another can be wired for electricity. Simultaneous work shortens the overall construction timeline. Factories are designed to optimize the flow of work. The movement of materials and the order of tasks are carefully planned to ensure maximum efficiency. Organized approach speeds up the construction process, resulting in a quicker and more reliable building method. Industrial manufacturing allows to provide cost-effective solutions. With standardization, it's possible to cut costs not only from the production, but also design works. The automation also helps to raise the efficiency of factory production and reduce the need for workforce. Additionally, factories can purchase materials in bulk, making the final product more affordable. Furthermore, the precision with which materials are cut and assembled in a factory setting leads to significantly less waste, reducing costs and contributing to more sustainable construction. Sustainability and environmental benefits are integral to modern construction practices. Houses produced in factories can be designed using advanced techniques and materials that enhance energy efficiency, leading to reduced overall energy consumption of the building. The centralization of production in factories also help to lower the carbon footprint by minimizing the need for extensive transportation of materials and products. Moreover, factories are better equipped to manage waste efficiently, including recycling materials, contributing to a more sustainable and eco-friendly construction process. Safety and working conditions are significantly improved in a factory setting, as there are fewer risks related to working at heights, handling heavy machinery, or dealing with unpredictable weather conditions. These factors are common hazards on construction sites, but are largely mitigated in a controlled factory environment. Prefabrication represents a significant shift in innovation of the construction industry, offering numerous advantages over traditional on-site building methods. The ability to produce homes with greater quality control, speed, cost-effectiveness, and sustainability makes this approach increasingly relevant in today's construction landscape. In the world of construction, efficiency and speed are key factors. Let's compare how industrial construction processes differs from traditional on-site construction. In industrial construction, materials and products are first gathered and brought to a house factory. Then, the production process takes place. For example, a 6-story modular building with 60 apartments can be produced in just 1.5 months, with the modular units reaching up to 90% completion before being transported to the site. Once the factory work is done, the partially completed building is transported to the construction site. The erection of the building can be completed in just 4 months. In total, the industrial construction process for a 6-story modular building takes approximately 5.5 months. When comparing it with a traditional on-site construction, then the entire construction process takes place on-site and requires whole 1 year from start to finish. As you can see, industrial construction, with its use of prefabrication in a factory, is much faster, sometimes even twice as fast when compared to traditional on-site construction. This is the reason why efficiency makes industrial construction an attractive option in the modern building industry. House factories operate as complex ecosystems, where various departments and processes work together seamlessly to ensure the smooth production and delivery of building components. This integrated approach is necessary to meet the diverse demands of each project, from initial sales and estimation to final assembly, logistics, and warranty services. By bringing together multiple disciplines such as design, procurement, production, quality control, and project management, house factories create a streamlined workflow that allows for efficient and high-quality production in a controlled environment. Each department and process within a house factory is interconnected, with the success of the entire operation depending on effective communication, precise planning, and coordinated execution. For example, project manager must work closely with procurement to ensure that all necessary project-based materials are available on time, while the production team relies on accurate designs and material availability to produce components without delays. Meanwhile, project managers oversee the entire process, ensuring that every stage aligns with the project's scope, budget, and timeline. This approach, supported by advanced technology and rigorous quality control measures, ensures that projects are delivered on time, within budget, and to the highest quality standards. It allows house factories to efficiently produce custom solutions tailored to specific client requirements. The ability to perform most of the construction in a factory setting, rather than on-site, minimizes risks, reduces waste, and improves overall efficiency. Prefabrication sets a high benchmark for sustainability, safety, and innovation in the construction industry. The sales process in house factories serves as the foundation for successful project execution, establishing a clear understanding of the customer's needs and ensuring that the factory's resources are aligned to meet these requirements. This process involves several key stages, each of which is critical to accurately defining project scope, estimating costs, and preparing and signing contracts that set the project in motion. The sales process includes understanding the needs of customers, effectively communicating the benefits of the products, and negotiating terms that satisfy both the buyer and the seller. The sale process begins with the initial customer engagement, where the sales team works closely with the potential client to understand their specific requirements, preferences, and project goals. This stage is crucial for gathering detailed information about project. The sales team must identify any special considerations, such as local building regulations, environmental factors, or custom design features that may impact the project. After the initial consultation, a preliminary estimation and feasibility analysis is conducted. During this phase, estimators collaborate with the design and procurement teams to develop a rough estimate of the project's costs, including material quantities, production time, and labor requirements. This also involves analyzing past projects, using pricing databases, and applying standard cost calculations based on the type and complexity of the project. Once the preliminary estimation is reviewed and refined, a detailed project proposal is prepared. This proposal includes a comprehensive breakdown of costs, timelines, and deliverables. It is developed in close cooperation with the design team to ensure that all technical specifications and design elements are accurately reflected in the cost estimation. During this stage, negotiations may take place to align the project scope and cost with the customer's budget and expectations. According to final price offer, a sales contract is prepared. This contract outlines all the agreed-upon terms, including the scope of work, delivery schedules, payment terms, and warranties. It serves as a binding document that clearly defines the responsibilities and obligations of both the house factory and the customer. The sales contract also includes clauses related to potential changes in project scope, unforeseen circumstances, and dispute resolution mechanisms to protect both parties' interests. Following the signing of the sales contract, a project handover meeting is conducted with appointed project manager. This meeting involves the sales team, the project manager, and representatives from design, production, and procurement departments. The purpose is to ensure a smooth transition from the sales phase to the project execution phase. During the meeting, all critical aspects of the project are reviewed. The project manager, now responsible for the overall execution of the project, coordinates with all involved departments to ensure that the project progresses according to plan. Project management in house factories involves overseeing the entire project from start until handing over the building's keys. Unlike traditional construction, much of the work in these projects is done off-site, in a factory, which requires careful coordination between the factory and the construction site to ensure everything aligns smoothly. The project manager acts as the primary liaison between various departments within the house factory, including design, procurement, production, and quality control. The project manager works closely with the design team to finalize the building designs based on customer specifications and regulatory requirements. For factory production, designs need to be finalized before production begins, as there's no room for adjustments once components are being manufactured. This requires precise planning and communication by project manager to secure that all parties are involved, from designers to contractors. Project manager's work includes also collaborating with production team and procurement team, but as well creating agreements with different counterparts and monitoring costs at every stage. Occasionally, project manager is responsible for the procurement of project-based materials, and planning the procurement effectively is needed, as timely delivery of materials and works are crucial for keeping the project on track. Maintaining clear and consistent communication with the customer is a key responsibility of the project manager. This involves regular updates on project progress, addressing any questions or concerns, and managing expectations throughout the project lifecycle. Project management is about balancing the buyer's objectives and factory's obligations. In addition, as majority of the buildings are built in different regions, it requires constant overview of local regulations and demands to meet them properly. Clear communication and coordination throughout the project is essential to ensure successful completion of every stage of the project. After the contract is signed, works related designing the building's structural elements, assembling units, and handling complementary tasks like electrical work, water, heating, and ventilation starts. To make sure the structure is safe and stable, engineers perform calculations to check loads and stresses. As well, fire modeling is made so that the building meets all the demand from fire safety perspective. The design process mainly relies on a 3D structural model, while creating a building information modeling, also called BIM model. BIM model is a digital representation of physical and functional characteristics of a building, which includes important material and technical details. Although 2D software can be used, it doesn't easily transfer data to the next production step. Detailed drawings and sketches are crucial to ensure the components are produced and assembled correctly. The level of the design detail depends on the factory. The standard structural solutions are usually described in work instructions and not duplicated in the production drawings. In more automated factories, drawings according to 3D modeling is exported to computer-controlled machine, although some tasks may still rely on separate drawings. Any design changes must be finalized before production, as modifications are not feasible once components are being fabricated. The production process in house factories involves transforming raw materials into finished building products through a series of carefully planned stages. It starts with planning, where the design and resources required for production are determined. This stage ensures that both planar elements, like walls, floors, and ceilings, and volumetric elements, such as nearly complete rooms, fit together perfectly at the appointed time and meet customer requirements. Detailed planning also sets the schedule and material needs for the project. The manufacturing stage is where the actual production takes place. Here, raw materials are converted into finished products, with flat planar elements and volumetric elements being produced under controlled conditions. Planar elements are standard components like walls, while volumetric elements are larger, more complete assemblies. These elements are designed for quick assembly at the construction site, minimizing construction time and risks. After manufacturing, the products are stored until they are ready for transportation. Efficient storage is essential to protect the products and maintain the overall efficiency of the supply chain. Quality control in house factories is a systematic process designed to ensure that every component and final product meets specific safety, durability, and performance standards. The process begins with the inspection of raw materials as they arrive at the factory. Each batch of materials, such as wood, boards, windows, is checked for quality defects like warping, impurities, or inconsistencies. Ensuring high-quality materials from the start is crucial to avoid issues in the later stages of construction. As the production process begins, in-process quality checks are performed at every stage of production. During assembly, workers monitor each step, from framing to finishing. These checks involve measuring dimensions, verifying alignments, and ensuring that every component fits together precisely according to the design specifications. This stage is critical because it allows for the early identification of errors or defects, which can be corrected before they affect the entire building. Once the individual modules or components are assembled, a final inspection is conducted to assess the overall quality of the product. This comprehensive inspection ensures that the product meets all design and safety standards before it leaves the factory. In addition to visual and structural inspections, performance testing is often conducted to simulate real-world conditions. This can include air tightness tests, water leakage checks, and electrical safety verifications. These tests help ensure that the house will function effectively and safely once it is installed on-site. Quality control in house factories is essential for maintaining the consistency, safety, and reliability of prefabricated homes, helping manufacturers deliver high-quality products that meet customer expectations and regulatory requirements. Logistics in a house factory is a crucial operation, involving the careful planning and management of materials as they move through the factory, from arrival to processing and final shipment. The factory is essentially a large logistics system where materials come in, go through various processes, and are eventually turned into end products that are shipped out. The efficient planning and optimization of material flow and storage are central to the factory's operation, as they directly impact the factory's effectiveness compared to traditional on-site construction. Logistics influence every aspect of factory design and operation. The goal is to minimize the movement and storage of products to increase efficiency. The layout of workstations, storage areas, and the distance materials must travel between them are all optimized to reduce time and effort. For instance, some transfers may be quick and straightforward along a production line, while others may require more complex equipment like bridge lifts or forklifts. Decisions about how much material to keep in stock depend on supply chain. Keeping too much material increases storage costs and the risk of damage, while keeping too little could halt production. Efficient logistics reduce the time materials spend in storage and on the production line, which lowers operational costs and speeds up product delivery to customers. Logistics is divided into 4 key areas: incoming materials, internal logistics within the factory, delivery logistics for finished goods, and storage. For incoming materials, logistics consider factors like how goods are unloaded and where they are placed. Different products have specific storage requirements, such as protection from moisture, which is a major risk in material handling. Internal logistics manage how materials move within the factory. In production lines, like those for wall elements, materials are processed and assembled in a sequence that keeps production flowing smoothly. The work is often organized into specific time cycles, where each task must be completed within a set period to keep the line moving efficiently. For delivery logistics, planning focuses on how finished products are transported to their destinations. Larger elements, like modules, require special transport arrangements, including permits and protection during transportation. It's also important to account for risks such as weather damage or condensation inside the packaging, which could occur during transport and storage. In essence, the factory's logistics system is designed to streamline the entire manufacturing process, reduce costs, and ensure the timely delivery of high-quality products to customers. The erection process on a construction site involves a carefully coordinated effort between various teams to ensure that prefabricated elements or modules are installed correctly and safely. Before installation begins, the site needs to plan how the elements or modules will be received, where they might be stored temporarily, when scaffoldings needs to be installed, and how and where the lifting will be done. This planning includes creating a detailed site layout that considers the location of cranes, lifting methods, and necessary safety precautions. Choosing the right crane involves evaluating its lifting capacity and reach, and selecting the appropriate lifting methods, such as straps or attachment points specific to each element. Safety is the most important during the lifting process. Workers must ensure that no one is beneath the lifted elements, that the fastening straps are undamaged, and lifting hooks are securely attached. all personnel must use appropriate safety gear. Coordination between the site management and installation team is essential, with agreements made regarding the use of site facilities such as restrooms, power sources, and waste disposal. Installers must adhere to site rules and safety protocols, including orientations and the use of required safety gear. The installation of wooden elements is managed by the site manager or installation foreman, who ensures that elements are placed in the correct order, connections are securely fastened, and the work is carried out safely. The foreman addresses any issues during installation and liaises with the broader site team to keep the process running smoothly. Planning for transportation is another crucial element of the process, as large trucks carrying the prefabricated components often face restrictions in navigating the site. Detailed route planning is necessary to avoid unsuitable areas such as soft ground or tight turns. Moisture protection management is critical during the erection process. Some elements cannot be installed in rainy conditions, so weather monitoring is necessary. Protective measures, such as using tents, may be required to shield the elements during installation and after. The order of installation is thoroughly planned, with specific sequences required to secure connections and attach elements properly. Installers must adhere to precise tolerances, ensuring that all measurements are accurate and connections are correctly executed. Quality control during the erection process includes photographing hidden structures, documenting installation tolerances, and confirming that all elements meet specified standards. Post-installation, the site must be cleaned, weather protections must be maintained, and additional tasks such as sealing and finishing of interior and exterior surfaces are completed. This thorough and detailed process ensures that the building is not only constructed efficiently, but also meets high standards of quality and safety. Factories offer a comprehensive warranty on all their wooden elements, reflecting to their confidence in the quality and durability of their products. This warranty covers defects in materials and workmanship under normal use and conditions. Should any issues arise, customers can contact a general contractor for assessment and resolution, which may include repair, replacement, or refund, depending on the nature of the defect. The warranty underscores a factory's commitment to customer satisfaction and long-term reliability of its products.